Hey everyone, thank you so much for watching this video. I'm going to be showing you how to turn one of these keychain luggage tags into one of 3 amazing projects. The first of which is an Arduino shield that you can use to burn the bootloaders onto Atmega 328 chips. This is a fantastic tool to have around if you like to do a lot of Arduino based projects and you like to order a lot of Atmega 328s in bulk. The second is an Arduino shield you can use to program the keychain that I showed you how to build in the last video, or just the Atmega 328 chips that already have the bootloader on them. Lastly, I'll show you how to turn this luggage tag into a motherboard that runs on Arduino software that you can use to power just about any electronics project that you may have in the future. So let's get started with a simple components list. These are all the components that you'll need to assemble the first project. You can find links to all of these components in the PDF file for the luggage tag at mechanicalmagnificus.com under links and documents, or just look in the description of the video. You're also going to need an Arduino Uno, a soldering iron, just a basic one will do, some lead-free solder, and then if you plan to go the next step with it, a voltmeter and a breadboard for tuning the buck converters. I'll start the assembly with the 28-pin socket. This holds the Atmega 328 chip in place. I have to hold it to the board before I solder. I'll put a tiny drop of super glue and then place it on the board, being sure to line up the notches on the bottom. While I'm at it, I'll also add a few more components, starting with the crystal oscillator. With components like these, I can hold them in place by bending up the wire leads by about 45 degrees. Once that's taken care of, it's time to add the 2 22 picofarad capacitors into the oval slots just above the oscillator. And just as before, I will hold them in place for more convenient soldering by bending up the leads by 45 degrees. And I will stick the resistor in just beside those, pressing it down until it lines up flush with the board. The pressure should hold it in place. Now, on to soldering. I find that a good technique for soldering is to first start by adding some tin to the end of your solder tip, and then hold it at 45 degrees to the components so that you're heating up both components simultaneously. And then add solder directly to the components themselves, not to the tip of the soldering iron. I'll go ahead and finish up all the components that are on this side before turning the board over and cleaning things up. With a pair of safety glasses on, just in case, I'll come in with a pair of tin snips or wire clippers and snip off the excess leads. Now I'll get out the Arduino Uno and start on the pin headers. I like to use the Arduino Uno as a holder for the pin header rails, as this makes it much easier to count out the number of pin headers that you need and trim them off. I'll do this for every one of the 4 female pin header sections on the Arduino Uno. I'll also break off one set of 3 male pin headers and one set of 2 male pin headers. These will become the 5 programming out pin heads for the programmer later on. Now, with all the pin headers ready to go and perfectly sized, it's time to add the shield on top. The Arduino underneath now acts as a perfect holder to keep things from moving while I solder. And afterwards, the Arduino shield will be easily removable. Now, to make this luggage tag function as a bootloader burner, it's time to solder the 4 SMD connections highlighted in solid white. To do this, I will form a small ball of solder on the end of the soldering iron, and then very quickly tap it in place in between the 2 contact plates. Now that the luggage tag is equipped to act as a bootload burning shield for Arduino, it's time to test it out. I'll first isolate the Arduino itself and upload the ISP program to it. Opening a new Arduino programming window, the Arduino ISP sketch can be found under File, Examples, and then Arduino ISP. I will verify that I have the right board selected in the ports, and then upload this to the Arduino. After that, I will put the luggage tag shield back on, and begin seating the fresh Atmega 328 chip. Careful to line up the notches. And also careful to apply an even pressure while forcing it in, just to make sure I'm not bending any of the pins. Now the complete assembly is ready to be plugged into a computer to start burning bootloaders. The first thing I'll do is go to Tools and verify that 3 things are correct. 1, that Arduino as ISP is checked. 2, that the port is correct. And 3, that the board I am using is correct. Once these things have been verified, I can simply hit Burn Bootloader. If everything was done properly, it should take a few moments, but should display Done Burning Bootloader when everything is complete. The new microcontroller is now able to accept and understand Arduino programming. On to project number 2, which is converting the luggage tag into a programmer for other projects and for 328 chips that already have the bootloader on them. To begin, I'll need to remove the SMD connections from the bootload burner configuration. I'll do this by melting the SMD connection with the end of the soldering iron and then wiping it onto a paper towel. I'll do this repeatedly for each connection until all connections are gone. Once that's all taken care of, I'll take the 5 programming out ports and begin on those, with a little bit of super glue to hold them in place. I'll turn the board over and solder them on. With that taken care of, I'll fill in the 3 SMD connections inside of the white outline box. The luggage tag can now be used as a programmer. To begin uploading codes, I will first remove the microcontroller from the Arduino Uno. Note that I'm not actually trimming anything here with the wire clippers, but just using the sharp point to pry it up gently. I've written original on the top of mine to make sure that it doesn't get mixed up. Now I'll place the newly made programming shield on top of the Arduino Uno and try it out on a few things. For example, the breadboard controller from the last video can actually be programmed with the luggage tag. The 5 programming in ports on the keychain fit perfectly with the 5 programming out pins of the luggage tag. One thing to watch out for is that these pins don't contact the metal housing of the USB connection box. A little tape on top of this will help to prevent that from being an issue. Here is what it will look like when it's ready to be plugged into a computer and programmed. For now, I'm going to focus on programming the 328 chip that I burned the bootloader onto earlier. With that seated comfortably and in the right orientation, I'll plug this into a computer and begin programming. The first program I'll upload to this is the Blink script, which can be found under File, Examples, and Basics. Assuming none of my settings changed from the last time I was in the programmer, I should be able to simply hit Upload and begin uploading. And if everything was done properly, it should compile for a moment, then upload, and then give the Done Uploading prompt. The last thing to do for this luggage tag is turn it into a standalone project controller, which I'll start by preparing the voltage regulator, a buck converter. With the 4 male pin headers placed into the board in their corresponding locations, I will place a buck converter on top of them with the arrow pointing towards the voltage out. This makes soldering the pins on exceptionally convenient. Now that the pins are soldered on, I can take the buck converter off of the luggage tag and place it into a breadboard. This will make it much easier to tune the buck converter to the 5 volts required for safe operation of the 328 chip. I go into detail on how to tune one of these buck converters in the keychain video, but for now, I'll skip to where I tune it to 5 volts and carry on. I'll prepare the buck converter for soldering with a tiny drop of super glue to hold it in place. Again, making sure that that arrow is pointed towards voltage out. And now to solder it on. And just to make things look nice, I'll trim off the excess pin header. The last thing to do to make this act as a standalone project controller is to solder all the SMD connections directly adjacent to the 328 chip. There is one SMD connection that is a different orientation than all the rest. This one actually connects the buck converter to the board. So, if I wanted to use a different power supply, I could simply leave that unsoldered and connect the other power supply between 5 volts and ground as noted on the board. Because I'm going to be using the buck converter, I'll go ahead and drop some solder in this SMD. And with that, the controller is ready to use. I'm going to test this by using the blink script, so first I need to give it something to blink. Utilizing the rails built into the board, I'll solder a potentiometer, or variable resistor, and LED in series between pin 13 and ground. I've only configured this luggage tag to blink a light on and off at a constant rate, but there's so much more you can do with it. Maybe you want a fan that turns on when it senses you're getting too hot, or lights for your car that change depending on how fast you're going. The possibilities are only limited by your own imagination. Whatever you end up doing with it, be sure to share it on all your social media with an @CalvinEngineering or #Magnificus so we can see. In any case, thank you so much for watching this video, and to my patrons for helping make it possible. Be sure to follow us on Twitter and Instagram for weekly project updates, and if you like what you see, consider becoming a part of the magic on Patreon and receive exclusive content and perks. Please let us know what you thought of this video, and until next time, be yourself and continue making life magnificent.